Ask my instructor 6.5.8. Find the length of the curve for x running between 1 and 27. I'm going to use the definition for arc length. However, instead of using f prime, I'm going to use the notation dy dx, and my reason for doing that is they gave the curve as y equals. So arc length is equal to the integral going from 1 to 27, because that was the range of our x values, of the square root of 1 plus dy dx quantity squared dx. And this is my function y. The first thing we need to do is find dy dx. After we find dy dx, we need to square it. After we square dy dx, we want to add 1 and simplify it as much as we can, because remember, this is going to go underneath a radical, so we want it as simple as possible. So when you add 1, you actually end up with a perfect square. And that takes a little bit of work to recognize that. But if you just view the entity as x to the 2/3, if you square x to the 2/3, if you square that value, you get x to the 4/3. And so that's really all that's going on. So, since it's a perfect square, then I can take its square root, and this is what I get. And so the length, usually we have to use a calculator to find arc length. In this case, because what was underneath the radical was a perfect square, we don't need to do that. All we do now is just integrate. After we integrate, we evaluate. But before I do that, I remind myself what 27 to the 1/3 power is and 27 to the 5/3. 27 to the 1/3 power is 3, and so to the 5/3 power is 3 to the 5th, which is 243. So I'm ready to evaluate, and then I just need one more final cleanup, and I get a length of 1,467 divided by 10. Let me know if you have any questions on this.